All right, now I'll go back to sharing my screen. So we come in, we just talking about synthetic division. We can find function values, which are equal to the remainder, we said. And then we can check if a number is a 0, because the remainder will equal 0 if that number is a 0. So now we know what we're going to use it for. Let's look at the steps I'm going to use for my synthetic division. All right, the first thing you're going to do, you're going to write out the coefficients. And the coefficients are just the numbers in front of my variables, okay? It's all the numbers of that polynomial. Here's the thing about the coefficients. If there are any missing terms, we must use a 0 as a placeholder for that term. So say I had x to the third plus 2x squared minus 5. I would have my x to the third term. I had my x squared term. But since I didn't have an x term, I would have to put a 0 for one of my coefficients. And then I would put my last number. I think I said a 5 or something. All right, so I'm going to write out those coefficients. I'm then going to use C, which is equal to the number being used. So if they want me to find function values and they gave me f of 5, C would be 5. If I was using synthetic division to test if a number was 0, if my number I'm testing is -2, then C would be -2, okay? All right, so I wrote out my coefficients. Then I'm going to draw a box under the coefficients. Now, it's not really a whole box. What I'm going to draw is going to look like this. It's going to be most of a box, but it's not going to be filled in right here, okay? So what's going to happen with this box? This part right here is what we call the quotient. Inside that little box there will end up being our remainder. All right, so I'm going to give y'all a chance to write that. So draw your box under the coefficients. Then what I'm going to do, so let me let one in real quick. All righty. So now I've got my coefficients. I've got my little box under it. Over here's my C. So the steps I'm going to start doing are I'm going to bring down the first coefficient, so I messed up that a little bit. So coefficient into the box. So I bring that first number straight down and put it into my box. Now, I'm going to start a little process. The number I brought down, so the number in the box, gets multiplied by C, and the answer is placed into the second column under the second coefficient. Now, these sound like a lot of complicated steps, but when you watch me do it, it's going to be a breeze. So now I've got that product in that second column under that second coefficient. So now what I'm going to do, I'm going to add that column together. So add the column together. And place answer in the box. So it'll basically be my second number that I've got in my box now. So what I'm going to do now is take that number, multiply by C, and put that answer in the third column. So you're going to just repeat the process until done. So what answer I'm looking for on these problems in college algebra is going to be in that remainder box, okay? So let me show you one of these problems worked out.
I have a question real quick before you do that. Can you work out number 3 on 8.3 whenever you get a chance? I had such a hard time with this one.
Okay, so let me maybe work one or two of these and then we'll hit your question up, okay?
Thank you.
Now, do you have the actual question?
I do, in front of me. Yeah.
Okay, that'll work. All right, so this here, we're going to use synthetic division to find the function values. So they're giving me f of x equals x to the third minus 13x squared plus 52x minus, what's that, 60. They want me to find f of 2, f of a negative 5, and then f of 6. So they want me to find 3 function values. Now, we know in the past, all you got to do is put the 2 in for all the x's, cube it, square it, and do all that order of operations. But we want y'all to see this with synthetic division because it's probably quicker and easier to work. You don't have to worry about order of operations on synthetic division. So y'all, here we go. My coefficients are 1, negative 13, 52, negative 60. You're always going to have one more coefficient than that degree. So since this is degree 3, we need 4 numbers. So we come down, we write our 1, negative 13, 52, and negative 60. I'm going to draw my box under that. Now remember, leave a little space in between because that's where the numbers are going to be added after we multiply. So under the last number, I'm going to draw the box like that. That's going to be my remainder. And remember, leave a little space in between. Over here is going to be my C. So remember, C is equal to the number you're putting in for your x's, basically. So C for us will be 2. All right, so y'all with me on that? Coefficients, bring the number over here you're looking at. Now, remember we said we bring the first coefficient into the box. So I'm going to draw an arrow, and that 1 goes right down into our box. Then we said, hey, you're going to multiply these numbers in the box by C. So remember, this is our C. So multiply that number by your C. So 1 times 2 is 2. We said put that answer in the next column. So y'all with me? Multiply by the C, get the next column. Then we said add that column together. So you're going to add that negative 13 and 2 and get me a negative 11. All right, so I got a number in the box, so we're going to repeat the process. That negative 11 multiplies by C, which gives me a negative 22. All right, you've got a column here. To get my next number in the box, I'm going to add that again. So 52 and a negative 22, that's going to give you 30. All right, got a number in the box. We got to multiply by C to get the last column. So 30 times 2 is 60. And look at that. Negative 60 plus 60 gives me a remainder of 0. So that means f of 2 equals 0. That's the same answer you would have got had you put a 2 in for all these x's and cubed it and squared it and multiplied it and added it and done all that, okay? So it's not too bad, is it? So y'all are saying no, I think. All right, so we bring down the
It looks pretty awesome.
So we bring down the same coefficients and check this next number. I'm going to draw my box again, my remainder, and this time my second one was a negative 5. And if you notice, this synthetic division don't really take up a lot of space. It's just boom, 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 you're done. So guess what? Bring the 1 straight down. First number always goes straight into that box. So my next process, 1 times that negative 5 gives me a negative 5. All right, let me let Gloria back in. Look like she got knocked off. All right, so negative 13 and negative 5 is a negative 18. The biggest mistake I get on this is people add negative 13 and they add negative 5 and make that a positive 18. But you can only do the like sign stuff, multiplying and dividing. Adding like signs, they keep that sign, okay? All right, ooh, here's a big one. Negative 18 times negative 5. I think that's a 90. So that's a positive 90. I bring into my next column. Ooh, it's tricky trying to keep up with all these coming into the meeting. All right, got them all in, it looks like. All right, I got a column here, so we add them together. That's going to give me, looks like 142. And then finally, 142 times that negative 5 will give me a negative 710. Final step to get that remainder is add those together. Negative 60, negative 710, give me a negative 770. So y'all, that means f of negative 5 is equal to that negative 770. So to me, that's probably easier than trying to cube a 5, square 5, and multiply and all that. You get pretty big numbers doing that either way. So that's what we had. One more to go, and that was that f of 6. So let me get over here. F of 6, we'll put a 6 into my C. My coefficients were 1, negative 13, 52, and negative 60. So then I'm going to draw the box. And I know that probably ain't really a box, but I didn't know what else to call that thing. All right, so what are y'all doing first?
Bring down
Drop the 1.
All right, so y'all drop that 1. So what you doing now?
1 times 6.
So 1 times 6 is 6. And y'all putting that in that second column. So then you're going to add that, let's see, negative 13 and 6.
Negative 7.
Negative 7. All right, now I'm going to do what?
Multiply negative 7 by 6.
All right, so let's see, that's a negative 42. So y'all are adding that. So let's see, 52 negative 42 would be what, a 10? Then y'all, the final step, multiply again. 10 times 6 is 60. So look at that. This also gives me a 0 remainder. So f of 6 equals 0. So guess what? You remember my first number, I had a 0 remainder. And f of 2 gave me 0. F of 6 gave me 0. So those two numbers would be zeros of that polynomial because that remainder was 0, okay? Which means that if you was to graph it, those are the 2 points for sure that is crossing over that x-axis. And then you can find that other one by doing more synthetic to them, okay? All right, so that's how you find function values. So this next example, we're going to use synthetic division to determine if the given numbers are zeros of the polynomial. Our polynomial is f of x is a 2x to the third plus 7x squared plus 32x minus 33. Oh no, y'all erase that. I wrote the wrong problem. Oh, my bad. All right, we want f of x equals 2x to the third plus 7x squared. So I started out right, but then I messed it up at this point. I needed a negative 11x plus 20. Now the numbers they want me to check are negative 5 and 3. Now, when you do this on the homework, put your answers in the same order they're giving you the numbers. So you're either going to get a yes or no on these, okay? So let's see, we're going to write our coefficients. Since this is a degree 3, we need to add 1 to that and have 4 numbers. So I got my 4 numbers, which means there's no missing terms. I got my x cubed term, which is a 2. My x squared term, which is a 7. My x term is a negative 11. And then my constant term is a 20. Draw your box. So the first thing I'm checking is going to be the negative 5. So what's going to tell us if this is a 0? Is the fact that we're going to get a 0 for that remainder, okay? So y'all, let's do it. We're going to bring the 2 down. 2 times negative 5 is negative 10. 7 and negative 10 will give you a negative 3. Negative 3 times negative 5 is 15. 15 and negative 11 give me what, a 4? 4 times negative 5 is negative 20. So I do get a 0 remainder. So that means definitely negative 5 is a 0 of that polynomial. So then you come in and check your second number they gave us, which was 3. Write those coefficients, 2, 7, negative 11, 20. So y'all, what I'm about to do is give y'all about a minute or two to tell me whether that 3 is a 0 of that or not. So some of y'all get to working that, all right?
It's not 0.
So not a 0 we got. So let's see if she is correct. So she brought down that 2. 2 times 3 gave her, what, a 6. 7 and 6 was 13. 13 times 3 was 39. Minus 11 was what, a 28. Woo, 28 times 3 was at 84. So you're definitely not getting a 0 out of that, right? So definitely you are correct. So it's sort of fun being able to do that, right?
Yeah.
All right, so I'm going to do one more, and then we're going to look at that question we had from a while ago. All right, we're given f of x equals, now these are your favorite numbers. I got an x to the 3rd, plus I got a 5/2 x squared, plus I got a 9/2 x, plus 9/2 is a negative 3/2 a 0. So let's see, we know our c's over here, it's a negative 3/2. Bring down your coefficient, so I have a degree 3, so add 1 to that means 4 numbers. So we got that, we got a 1, a 5/2, a 9/2, and a 9/2. Going to come down, draw my little box. All right, y'all, so let's see if negative 3/2 is a 0. So we're going to bring that 1 down. So let's see, 1 times a negative 3/2 is a negative 3/2. So my question is, what do I get when I have that 5/2 and that negative 3/2?
2/2, or
So 2/2, but I'm going to reduce that to a what?
yeah, 1.
A 1. So remember, you basically do auto operations on top, y'all, and put that over that common denominator. And then since we had a 2/2, like Richard said, we had to reduce that to a 1. But that's nice because 1 times negative 3/2 is negative 3/2. So how about 9/2 and your negative 3/2?
3.
Yeah, because I get 6/2 and we reduce that to a 3. Now watch this. 3 times negative 3/2. The 3 would be on top. So multiply top times top. Put that over bottom times bottom. So 3 times negative 3/2 should give you a negative 9/2, which gives me a big 0 remainder. So yes, negative 3/2 is definitely a 0. All right, so what I'm going to do, let me try to pull up this question on my text real quick. Oh, it looks like it went to my email, so let me see. And Gloria, what section did we say this was from?
8.3.
8.3. All right, so I'm in the email. I'm just waiting on the picture to pop up. Okay, so it's the same section basically. And it was doing like that problem I did. So this one had a -5 and a 3. They gave us f of x equals 3x to the 3rd minus 11x squared minus the 15x plus 25. So we're looking at something like yes, yes, no, no, yes, no, no, yes type answers, okay? So are these two numbers zeros? So remember, we're going to try that -5 first. We got 4 coefficients, which is what we needed because 3 plus 1. So let's write them down. 3, -11, -15, and 25. So can anybody tell me if that -5 is going to be a 0, yes or no?
No.
All right, so let's see. So you brought down that 3 times -5 was -15. Let's see, we add that together, we get what, a -26 times that -5. So that's going to be a positive, looks like 130. Minus 15 was 115. Woo, let me break out the calculator. These numbers are getting big. So 115 times -5. Well, I'm getting like a -575 plus 25, so -550. So that's definitely a no. Now on MATLAB, it'll have blanks like the number -5 is not a 0 because f of -5 equals -550. So you got to sort of tell it why it's not the 0, okay?
Okay, I got it.
And then when you check that 3, you're going to use those same numbers. And then come down with your box. So y'all, is 3 is 0?
No.
I get what, a -21 times 3 is what, -63. So that's a negative something, not no, it's not going to be a 0, right? So I get like a -38 or something like that. That what y'all got? So just be careful. These will either be, this one was no because of the -5 gave me a -550. This one was no because 3 gave me a -38. Okay.
Okay, thank you.
Mm-hmm. I sort of like synthetic division because I think it's sort of quick. It's better than trying to do order of operations on big polynomials, especially if they give you like x4s and x5s and all that fun stuff. So y'all, 8.4, I've seen a video on, but I sort of want to go through some of these trickier questions because they're really heavy on foiling in this section. So my first question says, find a polynomial. So I'll let y'all read this. It's telling me find a polynomial function of degree 3. So when they say degree 3, that means the highest exponent on your variables can be a 3. With real coefficients that has the following given zeros. They're giving me -1, 2, and -5. So let me write them 3 numbers down. -1, 2, and -5. These are my zeros, and I'm coming up with a degree 3 polynomial. So this is sort of like, we're going to work in reverse and find a polynomial that would have these kind of zeros. So think about this. If it's a 0, that means it's a solution. And if it's a solution, I can write it as x equals -1, x equals 2, x equals -5. right? So remember, that's what a solution is. It is a 0. Now, to find that polynomial, we need to work in reverse. So what I need on the right side of every one of these little bitty equations, I need a 0 on that right side. So to get a 0 on the right side, I add the opposites so that it moves it over to the other side. So on the first one, you're going to add 1 to both sides so that you get an x plus 1 equals 0. The second one, you would subtract 2 from both sides so that you get an x minus 2 equals 0. And then my third one, add 5 to both sides. Basically, all you're doing right here is since you need a 0 on the right side, you're moving the number over to the other side by changing its sign, okay? Now, I got 3 equations equal to 0. So it's true that I could write them all together and they could all still be equal to 0. If this factor is 0, the whole thing's 0. That factor is 0, the whole thing's 0, and so on. So do you see how you're sort of going in reverse here? Now, at this point, you got 3 sets of parentheses being multiplied. So you're going to have to get rid of these parentheses by multiplying 2 of these at a time. So I'm going to take the last 2 of these and I'm going to FOIL that. So if you don't want a big jumbled over here, come to the side and figure out what is x minus 2 times x plus 5. Because we'll bring down that x plus 1 and it's going to multiply by whatever answer we get right here. All right, so y'all are good at foiling, right? We've done that a little bit in here. So we're going to do the x times the x, make that an x squared. X times the 5 gives me a positive 5x. Negative 2 times x gives you negative 2x. And then negative 2 times 5 gives you a negative 10. Adding like terms in the middle, you get your x squared. 5 minus 2 gives me 3x. And then minus 10. That's now going to go into them parentheses. X squared plus 3x minus 10. So you just got to FOIL that one, and guess what? You've got to do that again to the bigger one. You're going to FOIL this. To FOIL this, you're going to take this x and multiply by all 3 of these terms. Then you're going to take that 1 and multiply by all 3 of these terms. Okay? So 2 things times 3 things, you're going to have 6 things going across there. So here we go. Now, since I'm only multiplying by x, all I'm going to do is add an x to everybody. X times x squared gives me an x to the 3rd. X times 3x gives me a 3x squared. X times negative 10 gives me a negative 10x. Now distribute to 1. 1 times x squared is x squared. 1 times 3x is 3x. And then 1 times negative 10 is negative 10. All equal to 0. So thankfully, we're done FOILing. But I got to do one more thing to this. And if you notice, I got to add these x squareds to those x squareds, and then these x's to those x's. So I'm going to bring down the x to the 3rd. We got 3x squared plus 1x squared. So 3 plus 1 gives me 4x squareds. Then I'm going to add that negative 10 to that positive 3. So negative 10 and 3 give me a negative 7x. At the end, I bring down my negative 10, and all this is equal to 0. But y'all, Math Lab's only worried about this part right here. because that is now my polynomial degree 3 because my highest exponent is a 3. So when they give you restrictions on that degree, you got to make sure you end up with that in your final answer, okay? So synthetic division probably a little easier than this stuff, right?
Yes.
Yes.
Well, guess what? It gets even better. So let me ask y'all this. So for question 2 and 3, let me give y'all a little bit of review on foiling things, okay? So this is a review getting me ready for, say, 2 and 3. So have y'all ever foiled imaginary numbers?
No.
No.
Well, guess what? Y'all about to foil imaginary numbers. But they're not bad. The only thing you got to remember, and you can even punch this on your calculator, anytime you get an I squared in your answer, you got to turn that into a -1. So y'all watch me. I'll even go to my calculator and show you that real quick. I'm going to stop that share and go to my calculator. To multiply the I stuff, do you see down here by the decimal? Right above the decimal is a blue I. So to get the I, you hit the blue button and the decimal, and it pops the I up there. And then come over here and square that. Because I want y'all to see that I squared equals -1. Okay? Also, if you want to multiply I stuff on here, like you want to do, say, a 3I times, say, a -3I, you can use that calculator and it'll punch that -3. It knows that those I squareds are going to turn into a -1. So 3 times 3 is -9, but that I times I is the I squared, which is -1. So that's going to turn that -9 into a +9. Okay, so let's go back and work this problem. All right, so watch this. Now, the nice thing about conjugate pairs of imaginary numbers like this is they get rid of the i's in the final answer, okay? And conjugate pairs look the same other than one's being added and one's being subtracted. So y'all, here we go. X times x is x squared. X times -2i is a -2ix. 2i times x is a +2ix. And then watch this. +2i times a -2i is a -4i squared. So we're going to combine like terms and take care of that I squared stuff. So bring down that x squared. Well, hey, what happens to my like terms?
Bye-bye.
Those things are gone, right? -2i, +2i, those canceled out. So my like terms in the middle cancel. So what am I going to turn that -4i squared into? So y'all, what you want to do, replace that I squared with a -1. So what's the -1 doing to that -4?
X plus 4.
Gonna make it a +4. There you go. So foiling conjugate pairs of imaginary numbers gets rid of the imaginary part of this problem, okay? And imaginary stuff always ends up with an x squared plus. Imaginaries will always have a plus there. All right, second review. How many have multiplied something like this? X minus square root of 2, x plus square root of 2. So any of y'all familiar with doing this one? So I'm not hearing too many yeses, huh? So here's the thing about a radical. A radical times itself. So if the number under your radicals matches, then when you multiply those radicals, you get a square root of a squared. But y'all, what's the square root of a squared? It's just a. So anytime you multiply radical times itself, it gives you what was under that radical, okay? Now, these are conjugate pairs. One's being subtracted, one's being added. So the nice thing about FOIL conjugate pairs with radicals, the radicals go away. So here we go. X times x, x squared. X times the square root of 2 is a positive square root of 2, x. Now remember, the x cannot go under the radical because stuff outside of radicals cannot multiply by stuff inside the radical, okay? Same thing here. Negative square root of times x is just a negative square root of 2 times x. Now, I'll work this out the long way. I'll say negative square root of 2 times a positive square root of 2 is a negative square root of 4. So 2 times 2 under the radical gave me 4. So watch this. What happens to these like terms? They're going to cancel because you got a positive square root of 2 and a negative square root of 2. That's going to give you a big 0 for those x's. Bring down that x squared. This is minus, so bring down your minus. And then at the end, you're going to put the square root of 4, which is 2. So you could have put a 2 right here instead of a square root of 4, okay? Because you realize, remember, that a radical times itself would have gave me the 2 had I chose that, okay? Now notice this. When you FOIL conjugate pairs of radicals, you always end up with a minus in the middle. Imaginary gives you a positive in the middle. Radicals give you a negative. All right, so hopefully that'll spark your memories about these. And I don't even know if they do these anymore in the schools. So y'all think y'all got them now? Because I'm about to do some problems with that kind of stuff, okay? So here we go. Find a polynomial. So we want a polynomial with zeros of 2, 7i, negative 7i.
Let me go back to this other one, see what's up. I want to test the user.
So we know that since these are zeros, they're also solutions. So x equals 2,
Let me go back and go through
x
all
equals 7i,
these.
x
Yeah.
equals a
Let me go through
negative
and see
7i.
the answers to these.
So you do your test on Fridays.
Yeah, I will. Because I'll be able to do all my homework today. I'll finish it all today.
You can do your test tomorrow.
All right, y'all. So remember, I need zeros on the right side, so I'm going to subtract 2, subtract 7i, and then add 7i. So here, subtract 7i from both sides. All right, since I got 3 equations equal to 0, I can now put all of them in parentheses. All equal to my 0 still. So I would be very, very picky what order I FOIL these. I would definitely FOIL this imaginary stuff first. If you start with x minus 2 in one of these, it's going to get ugly. It'll all work out in the end, but it's a lot uglier process, all right? So we want to bring down that x minus 2, and we're going to figure out on the side what this equals when we FOILed it. So here we go, x minus 7i times x plus 7i. So that's our side work again. So x times x is x squared. X times 7i is a 7ix. Negative 7i times x is a negative 7ix. And then y'all, negative 7i times a positive 7i is a negative 49i squared. So notice the middles 100% are going to cancel. So all I got is my x squared. And then what's the negative 49i squared going to give me? Because remember, I squared equals negative 1. Negative 1 times negative 49, make that a positive 49. Now, y'all, that part you could do on the calculator. Negative 7i times 7i. Calculator's going to give you a positive 49 for that, okay? All right, so let's plop that in here. X squared plus 49. But I will say, at least when you FOIL these, you only got 2 terms instead of 3 like I had a while ago, okay? All right, distribute the x, and then we'll distribute that negative 2. So x times x squared gave me an x to the third. X times 49 gave me 49x. Negative 2 times x squared is a negative 2x squared. Negative 2 times 49 is a negative 98, all equal to my 0. So I think I would probably only do one more thing to that, and that's put it in descending order of those exponents. So x3's first, minus 2x squared, then my 49x minus my 98 equal to 0. So what Math Lab wants is that little polynomial right there. And if you notice, the number of zeros y'all I'm given is equal to the degree of your final answer, okay? All right, let me see what I'm on here. So first part of 8.4, you're going to be doing a lot of FOILing, okay? So let me go in and do these kind of questions. So these are some little properties about zeros. So imaginary zeros and radical zeros always come in conjugate pairs. And that's because when you take square roots of stuff, it can come out positive or it can come out negative. That's why that plus or minus is in front of that big radical on that quadratic formula. All right, knowing that, I'm gonna see if y'all can answer this one. Suppose a degree 4 polynomial has zeros of negative 4, square root of 3, and 13 over 4. What is the other 0? Because that's a degree 4, so it has 4 zeros. They gave me 3. What's the one I don't have written down?
Negative square root of 3.
Oh man, that was quick. Negative square root of 3. because we just said right here they come in conjugate pairs. So good job. So do the same thing to this one. So once again, it's a degree 4 polynomial. Has zeros of 3 plus 2y and 3 plus a square root of 2. What are the other zeros?
3 minus 2i
Oh, wow. 3 minus 2i. That's very good.
and 3 minus square root of 2.
Awesome. Notice we didn't change the 3. We only changed the part where the radicals were, or the imaginary. So good job. So y'all, here we go. I'm going to show you why you had to learn synthetic division today. So let's see. We still got a little time left, right? So let's see. So a polynomial has the given 0. Find the other zeros. So let's get our polynomial. F of x is going to equal x to the 4th plus 7x squared minus 144. And they're telling me 4i is a 0. I think I write too hard on my paper so it starts wanting to fold. So let me put a holder over here. All righty. How many coefficients should I have? Because that's a degree 4, which means I need 5 coefficients, but I only see 3 numbers. So here we go. We know the x4 term is a 1. There's not an x to the 3rd term, so I'm going to add a 0. Y'all with me on that? I have my x squared term, which is a 7. I do not have my x term, so it's going to be a 0. I do have my number at the end, which is negative 144. So degree 4 add 1, you got to have 5 numbers. So then I'm going to bring down my little box. So my first C they gave me was 4i. So y'all, let me tell you what's going to happen when you're trying to find all the zeros. We use the first 0 they gave us. We better get a 0 remainder, because if we don't get a 0 remainder, that means we did a mistake, because they told me this was a 0. So what happens when you factor out this one and get your remainder? The numbers that are left under the box right here will be the automatic coefficients of the next synthetic division. So it keeps going down. So since I have a degree 4, I'm going to get 4 zeros. The last 2 zeros I'm always going to get using my quad formula. And that'll be when there's 3 numbers under this part, okay? So the first step we'll have 4, because we're going to bring down to 1. 1 times 4i is 4i. 0 plus 4i is 4i. So y'all, here's my question. What is 4i times 4i going to give me?
Negative 4? No, negative 16.
Negative 16. Because remember, 4 times 4 was 16, but that I times I made that a negative 1. So good job on that. 7 and negative 16 is a negative 9. So then you're doing it again, but now negative 9 times 4i is a negative 36i. Whoop, can't hardly see my eye good, so maybe that's better. Negative 36i and 0. Negative 36i. So guess what that negative 36i times that 4i is going to give me? Well, I know what it better give me, right? It better give me a positive 144. Right? So I got to get my zero remainder there. So now what we do, since we still got 4 numbers, use these as the coefficients of the next synthetic division. So I know my coefficients are going to be 1, 4i, negative 9, negative 36i. I'm going to draw my box. Now, since we're starting with 4 coefficients, it's going to put 3 numbers under the box. That'll give me A, B, and C for my quad, okay? Uh-oh. Y'all, I'm sort of lost. I don't have an under C. So what's the next thing I need to check?
Zero.
Well, 0 could be a 0, but it might not be a 0. But I got one thing I can use that is guaranteed to work. Oh, y'all just did 2 problems doing this. When y'all
Negative
found,
4i.
huh?
Would you use negative 4i?
I would definitely use negative 4i because we said they come in conjugate pairs. So y'all with me? If I give you an imaginary, you automatically, if you're finding zeros, got to use that other one, okay? Now, bring the 1 down. 1 times negative 4i is a negative 4i. Well, that's going to give me a 0 when I add it. 0 times negative 4i is a 0. So now you got negative 9 plus 0, which is what, negative 9? And guess what that negative 9 times negative 4i will give me? It's going to give me a positive 36i, which now gives us a remainder of 0. So the first of the missing zeros is negative 4i. Y'all got 3 numbers. Guess what you're using? One possible thing, if you want to use the calculator, you can now use quad and throw that in quad and it'll spit it out quick. Or watch what you can do. This is now a quadratic under here. That is 1x squared plus 0x's minus 9. If I set that equal to 0, I can get them 2 numbers pretty quick. Y'all remember I showed y'all how to take square roots? Add 9 and 9. X squared equals 9. Then you're going to take a square root of both sides so that x equals a plus or minus 3. Okay, but if you spit 1, 0, negative 9 in quad, it's going to spit out a 3, negative 3 really quick. So my other 2 zeros were 3 and negative 3. So really, these are not bad if you get the hang of my synthetic division, okay? All right, y'all, so let me see. I'm going to flip this over. So this one's doing the same thing. I'm giving you 1, 0. We're going to find the rest. So I got f of x equals x to the third plus 3x squared minus 2x. Oh, looks like a minus 6. The 0 they want me to have So the 0 equals, let's see, what was that? -3. So since this is a degree 3, once we pull that -3 out as a 0, I'll only have 3 numbers left, so I can jump right into the quad at that point, okay? All right, so I'm going to write these numbers. 1, 3, -2, -6. They gave me my first 0, which was -3. So we should get a 0 over here in our remainder, and then these 3 we're going to hit with the quad or whatever we want to do, okay? All right, so let's see. I'm going to bring that down. 1 times -3 is -3. Plus 3 is 0. 0 times -3 is 0. -2 plus 0 is -2. And here we go. Negative times negative is going to make that, what, a +6, which gives me my 0 remainder. So since you got 3 numbers under here, this is the x squared column. So it's like 1x squared plus 0 x's minus 2. So if you want to, or you can come in quad, A is 1, B is 0, C is -2. Either way. So y'all watch this. Quick way, add 2. Then take square roots of both sides. That x is now a plus or negative. Well, guess what? I cannot do a square root of 2, so that's just going to stay as a radical. So they had -3 as a 0. My other zeros were plus or minus square root of 2. And we knew that because radicals have to come in conjugate pairs, okay? All right, so I really think I need to show y'all this question here. And then I'll let y'all have at it. And then what we can't figure out on homework, I'll fix y'all Monday, or y'all can even email me or something, okay? This is called finding all rational, finding all rational, what's possible, oh my bad, finding all possible rational zeros. So what they're meaning, all the zeros that I can write as a fraction. So radicals you can't write as a fraction. Imaginary, those are not rational zeros. So we're looking at all the possible zeros that could be integers or fractions. So we got what we call P over Q. So to find all rational zeros, you're going to take every factor of the last number, and I'll call that P, and divide by every factor of the first number. By doing that, that will give you all the possible numbers that you could check as zeros for these polynomials. So you're always going to have a plus or minus factors of P divided by the factors of the Q. So let me show y'all an example. So I will do P of X equals 22x to the third minus 36x squared plus 48x minus 21. So what you want to do is figure out your P, which is the last number. So P is 21. So all the factors of 21, that would be a 1, 3, 7, and 21. Then we find all the factors of Q, which is the first number. That's going to be the 22. So let's see, factors of 22 would be 1, 2, 11, and 22. So I need all the combinations of my P factors divided by my Q. So I'm going to start with P of 1. That could be a plus or minus 1 divided by 1. It could be a plus or minus 1 divided by 2. Y'all following me? I'm taking that 1 and dividing by all 4 of these factors. That could be a plus or minus 1 divided by 11, plus or minus 1 divided by 22. Now, can you simplify any of these fractions?
Yes, 1 divided by 1.
Yeah, that's going to be a plus or minus
1.
1. There you go. So we've done the 1. Now let's do that with the 3. So plus or minus 3 divided by 1, plus or minus 3 divided by 2, plus or minus 3 divided by 11, and then plus or minus 3 divided by 22. Once again, you will have to simplify that one with the 1 on the bottom and make that a plus or minus 3. So that takes care of the 3. Do that with the 7. 7 over 2, 7 over 11, 7 over 22, and once again, make that a plus or minus 7 on the top. Takes care of the 7, and then finally, we do that with the 21. 21 over 2, plus or minus 21 over 11, plus or minus 21 over 22, and then the only one I can simplify is that top one. So you'll have an answer with all these, all these, all of those, and all of those listed as your possible rational zeros. So I'm guaranteed for the zeros to be one of these numbers here, okay? But on this one, we didn't have to find it. I just wanted to. Now, I'm going to work one more problem to show y'all that I probably won't do that. I'm going to show y'all how to graph the function and guess that away, okay? Oh, no, I don't have that problem. I have to go on to, let me pull up my MATLAB page. So this will be one like you'll see at the very end of this. So I'm going to go, I'm on the wrong homework. Let me shut this one down. Come on. So I'm doing 8.4. So this will be the last one I want to do with you, okay? So let me find 8.4. Now y'all remember this, I made tomorrow easier, so all we'll work on tomorrow that I'm sending you a video for is 5.1, and it's a very short section, okay? And y'all already know how to find domain. It's just using bigger equations on the bottom. So y'all, let me get my question here. My MATLAB is sort of slow. I can probably put y'all on with me, okay? So let's go to my actual homework page now. And I'm going to go to one of the last questions on here. So 18 sounds good. And we'll write this down and I'll show y'all how I would work this one, okay? So we're going to find the zeros and the other zeros. So they're giving us f of x equals x to the 4th minus 10x to the 3rd minus 62x squared minus 78x minus 27. Now, then it says part B, factor into linear factors. That just means put it back in parentheses, sort of like I did a while ago when we was finding them polynomials. So the first thing we want to do is figure out some of these zeros, and they didn't give me none to start with. So watch what we're going to do. We're going to go to our calculator. So let me share my calculator screen. We're going to let this calculator find some zeros for us. So I'm going to go over here and I'm going to go to my y equals. I'm going to clear that out. And I'm going to put in my polynomial, which was x to the fourth minus 10x to the third minus 62x squared minus 78x minus 27. Now, here's the thing. If y'all want to find all them possible rational zeros on this and then start checking all them numbers using synthetic division, you got to get a remainder of 0 with that synthetic division for it to be a 0 actually. But y'all watch this. We're going to graph it. We just looking for where this crosses that x-axis. So I got two possibilities for sure. It looks like it's crossing right there at -2. Now, if you want to make sure, go to second graph and pull up your table. You're looking for these y values of 0. I got one at -3. I got a 0 at -1. So I could use either of those as my first 0. So let's remember that calculator gave me -3 and -1. So let's go back to our paper. So y'all, that is a lot easier than trying to do synthetic division a whole lot of times to get a 0, okay? So I got my coefficients. That's a degree 4. I need 5 numbers, and I got my 5 numbers. So 1, -10, -62, -78, -27. Draw our box. The first one, I'll try that -3 because it came first for me. So I better get a 0. So here we go. Bring down to 1. 1 times -3, -3. Add that to -10, -13. Negative times negative makes that a positive 39. So what I got now, a -62 plus 39 should give me a -23 times 3. That's negative, so that's going to be a positive 69 minus 78. 69 give you -9. And y'all look at that. -9 times -3 is 27. So I got my first 0, which is -3. So I'm going to write my zeros. So I got -3 so far. So now, we're going to use these coefficients now. Remember, I still got 4 numbers. So I'm going to use these coefficients for my next synthetic division. Cannot use that quad till I got it down to 3. So we got a 1, -13, -23, -9. Draw my box. And remember, I also knew that -1 was where that crossed that x-axis. So I'm going to use -1 next. We should get a 0 here. So here we go. 1 down. 1 times -1 is -1. Plus -13 is -14. Times -1 makes that a positive 14. Well, what are we getting? -23 and 14 is like a -9. And then -9 times -1 is positive 9. And there's my 0 remainder. So I have confirmed that -1 is a 0. So now I'm going to use quad to get my last two. So we can go to our calculator, program, go to 4 for quad on mine, hit enter. A was 1, enter. B was negative 14, enter. C was a negative 9, enter. I don't want decimals, so I'm going to hit enter one more time. And I get 7 plus or minus square root of 58. So those will be my last two zeros. 7 plus square root of 58, 7 minus square root of 58. So let me go back to my paper. I wrote them down now. So the 2 zeros my calculator gave me. So I got all 4 of my zeros. So now we're good on that. Now it said write as linear factors. So they're going to have f of x equals. What we got to do, since we have 4 zeros, we're going to have 4 pair of parentheses. And if you remember, when they're in factor form, they always have opposite signs than the zeros. So if that's a negative 3, the first factor will be x plus 3. That's a negative 1. Second factor is x plus 1. This is a positive 7 plus square root of 48. That's going to be a negative 7 minus square root of 58. And then my last one, that's a 7 minus square root of 58. That's going to be a negative 7 plus square root of 58. So the 7 has to be negative for both of those because it was positive up here. And then basically you're just swapping them radicals around, making this one negative and that one positive. That is now my linear factors. So y'all, if y'all notice, 8-3, not too bad, but 8-4, we got a little bit of stuff in here, okay? So I sent y'all videos last night on 8-4 if you need more help sort of going through them homework problems. Because I think on them videos, I pretty much go through a lot of them. Woo, a lot of talking today, right? So one thing, did y'all learn synthetic division today?
Yes, we did.
And you learned how to FOIL, right? All right, so y'all remember, unfortunately, y'all don't have a lab on Friday. So what I will do, if y'all are having issues on homework sometimes, if I'm available, I will jump on Zoom with you. And sometimes we can sort of work through the problems doing that, okay? Or I can usually answer your emails and answer a lot of times what you got issues on doing that. So I'm going to stop this recording.